It is well said that a picture is worth 1,000 words. In mathematics, Venn diagrams are also a kind of pictures or diagrams that are used to show relationships between sets. Venn diagrams were invented by a British logician named John Venn as a way of picturing relationships between different sets. To draw a Venn diagram, first we draw a rectangle which is called a universal set. A universal set is a set that contains all objects under consideration. After this, different sets can be drawn using circles as shown here. Let's discuss an example. Here is the list of some aquatic and flightless birds: ostrich, emu, kiwi, parrot, eagle, penguin, swan, duck, and geese. We can classify these birds as aquatic birds and flightless birds using Venn diagram. Here, the universal set is the set of all birds. Let U be the universal set of birds, A the set of flightless birds, and B be the set of aquatic birds. We draw circles to display the classifications of birds. Now, we will classify the birds using Venn diagram. Ostrich, emu, kiwi, and penguin are all flightless birds, so they belong to set A. Penguin, swan, duck, and geese are all aquatic birds, so they belong to set B. Parrot and eagle both are neither flightless birds nor aquatic birds. However, they are birds. They fit inside our universal set, but outside the circles. Notice that penguin is listed in both of the circles. In Venn diagram, we can show this overlap in classification of birds by overlapping these circles. In the Venn diagram, we'll have to write only penguin in the overlapped portion. The overlapped portion of the two circles containing penguin is called the intersection of two sets, and the birds ostrich, emu, kiwi, penguin, swan, duck, and geese in two circles along with the overlapped part is called the union of two sets. Venn diagrams can be used in set notation like A union B, A intersection B, complement of set A, the set of elements in B but not in A, the set of elements in A but not in B, symmetric difference of sets A and B.
Recognize how Venn diagrams are used to show relationship between elements of different sets. Let us consider 10 friends A, B, C, D, E, F, G, H, I, and J. Let us consider those as universal set. Now, let us group them in a set who plays football. Let us form another set who plays cricket. Let us represent their relationship with the help of Venn diagrams. Let us first collect those who plays football. Cricket and football. The region shaded in green represents the children who play both football and cricket. It is that area which is common to both the sets. Similarly, the region in blue shows the children who do not play football. Thus, Venn diagram is a good tool to represent relationship between different sets. In a Venn diagram, the elements of sets are written in their respective circles. In the given example, one circle has elements that are multiples of 3. Another circle has elements that are multiples of 5. Here, the common region shows the common multiples of 3 and 5. Let us take an example for better understanding of the Venn diagram.
Now we will learn about the union of sets, intersection of sets, difference of sets, and complement of a set.
Union of sets. Union of two sets A and B is the set which consists of all the elements of set A and set B with their common elements taken only once. The shaded region represents the union of set A and set B.
Let us work out an example. If A is the set of
The intersection of sets A and B is the set of all the common elements of both the sets. The shaded region represents the intersection of set A and set B.
Let us take the same example and
Properties of operations of
law of
distributive law by Venn diagrams. The shaded region represents the union of set B and C. Here we have the images difference of sets. Definition: the difference of sets A and B written as A minus B is the set of all the elements of A that do not belong to B. Here we have Venn diagram of A minus B. B minus A is the set of elements that belong to B but not to A. The shaded region represents the difference B minus A. Let us do complement of a set. If U is the universal set, then complement of set A is the set of all the elements of U that are not the elements of A. The complement. Let us find properties of complements. Complement law. The intersection of a set.
De Morgan's law. The complement of the union of two sets is the intersection of their complements. It can be verified using Venn diagrams as shown. The complement of the intersection of two sets is the union of their complements. It can be verified using Venn diagrams as shown.
Law of double complementation. If n, so the number of elements in A union B is equal to number of elements in A minus B. Let us work. If the sets A, B and C are three finite sets in U, then the number of elements in A union B union C is equal to the number of elements in A plus number of elements in B plus number of elements in C minus the number of elements in B intersection C minus number of elements in A intersection B minus number of elements in A intersection C plus number of elements in A intersection B. We get the desired result.
Solution. Observe the following table obtained during the survey of 25 students. On the basis of given data, find the number of students. Solution.
Let M, B, and C denote the sets of students who choose to study mathematics, physics, and chemistry respectively. Consider the Venn diagram shown below. Here A, B, C, D, E, F, and G denote the number of students in the respective regions. The number of students in B intersection C intersection M is equal to 3. To find the number of students who choose to study physics and chemistry but not mathematics, let us first find the value of F. We have number of students who study physics and chemistry as 4. It implies F is equal to 1. Thus, the number of students who choose to study physics and chemistry but not mathematics is equal to 1. Now, to find the number of students who study mathematics only, we have to find the values of B and D. We have the number of students who study mathematics and physics as 9. It gives B is equal to 6. Also, the number of students who study mathematics and chemistry is equal to 5. It gives D as 2. Now, the number of students who study mathematics is equal to 15. It gives A as 4. Thus, the students who study mathematics only are 4. The number of students who study physics is equal to 12. It gives C as 2. Thus, the total number of students who study physics only is equal to 2. We have given the number of students who choose chemistry is equal to 11. From this, we get the value of G equal to 5. Thus, students who study chemistry only is equal to 5. So, the number of students who study only one of the subjects is equal to 4 plus 2 plus 5, that is equal to 11. Now, to find the number of students who choose to study at least one of the 3 subjects, we add the values of A, B, C, D, E, F, and G. On adding the values, we get the result as 23. Thus, the number of students who choose to study at least one of the 3 subjects is equal to 23. Hence, the number of students who choose to study none of the subjects is equal to 25 minus 23, which is 2.